Alright, boys and girls, welcome to our video lesson on factoring. What we're going to do is we're going to start by doing some foiling, which is actually how we get to factoring. So we're going to start with a little bit of algebra, foiling. When you FOIL, you are actually multiplying two binomials. Notice that both of these terms right here are binomials, okay, because they have two terms each. In the first one, the first term is x, the second term is 2. In the second factor, the first term is x, and the second term is 3. So when I multiply two binomials, I'm going to do it in the FOIL fashion, which is first, outer, inner, last. So what I'm going to do here is I'm going to multiply the first, x times x, and I get x squared. I'm then going to multiply the outers, which is x and 3, so I multiply x times 3, which is 3x. I'm then going to multiply the inners, which is 2 times x. Notice these are the inside terms, 2x. And then I'm going to multiply the last terms, which is the 2 and the 3, which is 2 times 3 is 6. I'm then going to combine my like terms. I have x squared plus 3x plus 2x plus 6. I can combine the 3x and 2x. I get x squared plus 5x plus 6. What we just did there is we multiplied. We multiplied two binomials, and their product was a trinomial. Their product in this case was a trinomial, x squared plus 5x plus 6. When we factor, we're going to go in reverse. We're going to start with the trinomial, and we're going to go back to the binomial factors. In other words, we're going to go back to here. When we FOIL, we go from the factors to the product, and when I factor, I'm going from the product to my factors. All right, folks, let's do a few examples. I did one here a couple of minutes ago and it didn't record, so it's written here, but let's just run through it real quick and then you can try some on your own. This first one I'm going to FOIL two binomials. Again, I have a first term and a second term times a first term and a second term, so I'm going to use the FOIL method. So I do x times x, which is x squared, x times neg 7, neg 7x. I'm going to do 5 times x, which is positive 5x, and 5 times neg 7, which is neg 35. I combine my like terms right here. I'm going to get x squared minus 7x plus 5x is negative 2x minus 35. So this is my factored form, and this is my multiplied form, okay? Why don't you guys try these next two on your own, stop the tape, and then we'll get ourselves all caught up. Multiply these two binomials out using the FOIL method. Go. Okay, so as we look at these last two, when you FOIL this first one, we get x squared plus 8x minus 3x right here, and our last, or minus 3 times positive 8, is neg 24. I can combine my like terms here in the middle, the x terms. I get x squared plus 5x minus 24. When I FOIL this one down at the bottom, they're larger numbers, but that's okay. Let's do our first terms first. So the first is 3x times 4x, 12x squared. The outers, 3x times neg 3 is neg 9x. My inners, 12 times 4x is plus 48x. And now my last terms is positive 12 times neg 3 is neg 36. Combine my x terms in the middle. I'm going to get 12x squared plus 39x minus 36. Notice I don't combine my unlike terms, right? Can't combine the x squared with the x or the x with the numbers. Okay. Okay, you've seen these before, quite a few times before, but if you have not written these down somewhere in your life, you can do it now. These are our perfect squares. Like, for example, 6 squared is 36. 6 times 6 is 36. 17 squared, 17 times 17 is 289. You know, if you don't have these somewhere, write these down. You want to know them. I don't want you to mesmerize them, but certainly the second 10, which we don't see as often, when you see these numbers, you should at least kind of have them ring a bell and say, I think that is a perfect square. Okay, these are our steps to factoring. Now we're going to talk about factoring. Factoring is the reverse, is the undoing of multiplying. It's like dividing. Factoring is like dividing, okay? We're going to undo multiplying. Here are our steps to factoring. List the terms in descending order, so put the highest powers first, and then go down in order. We're going to look for a common factor in each term, factor out the common monomial factor. We're going to look for special products, and we'll talk about what the special products are. They're these right here. And you will do differences of cubes and sums of cubes next year in Algebra 2. We won't worry about them too much right now, but they do exist. Just know that they're out there. Okay. Then we're going to talk about trinomial factoring. And we will, not today, but at some point you will learn or review factoring by grouping. Okay. And your last step to factoring is always check the primeness of each factor. So we're going to start by doing the first step of factoring, which is monomial factoring, factoring out a common factor. Don't forget that factoring, again, is the inverse, it's the reverse, it's the undoing of multiplying. It's like dividing. Factors are expressions that you multiply to get a product. 3 times 4, 3 and 4 are my factors, 12 is the product. That's the answer when you multiply, and you guys know that. So let's look at the first one. We can see we have 3x plus 6. I'm going to factor that by I see that there is a common factor in each term. The common factor in each of these terms is 3. I can divide each of those things, those terms, they're not things, they're terms, by 3. When I do that, when I divide each of those by 3, I'm not going to lose that 3. I'm going to put it out front. That's my first factor. And when I divide 3x by 3, I get 1x. And when I divide 6 by 3, I get 2. Notice what I have now here is I'm like reverse distributing. I have a factors of 3. Let me get my arrow. I have a factor of 3 and a factor of x plus 2. If I were to distribute, in other words, if I were to distribute the 3 to x plus 2, that would be like multiplying. I would end up with 3 times x is 3x, and 3 times 2 is 6. Notice I'm right back where I started. In the second one, I have a common factor of x. So what I'm going to do here is I'm going to factor each of these terms by x. I'm going to divide an x out of each. So I don't want to lose that factor. I have an x. Build my house. Now, when I divide x squared by x, that gives me x squared divided by x. Be careful, it's not 2. X squared divided by x is x, because x times x is x squared. And 9x divided by x is negative 9. It's actually negative 9x divided by x is negative 9. So this is now my factored form. If I were to distribute, go back, let's see if it checks. X times x is x squared. And x times neg 9 is neg 9x. This is where I started, so that works. All right, you guys, try this last one on your own. We need to get a common factor. I'm going to give you a clue. The common factor is 5x. Factor a 5x out of each of those, and I'll be right back. Okay, when you factored out the 5x, we factored a 5x out of each of these. Okay. I get, for my first term, 10xy divided by 5x is 2y. 5x divided by 5x, careful, don't lose that. That becomes 1. And 25x squared divided by 5x is 5x. Let's check this and make sure we get the right answer. I'll get my marker. There's an equal sign. 5x times 10 times 2y is 10xy. 5x times neg 1 is neg 5x. And 5x times 5x is positive 25x squared. And sure enough, we end up right back where we started. This, again, is our product form, and this is our factored form. Okay? This would be our product, and this is our factored form right here. Okay, let's do our next type of factoring, which is factoring differences of squares. This is one of our special products. This is, we're going to factor 2 a two-termed expression. This is a binomial, so it's a two-termed expression where each of our terms are perfect squares. Notice that x squared is a perfect squared, it's x squared, and 9 is a perfect square, it's 3 squared. So we always follow this pattern, a squared minus b squared, a difference of squares. Notice difference minus. Difference of squares is equal to the factors a minus b times a plus b. And the reason for that is if I FOIL this out, a times a is a squared, a times positive b is plus ab, negative b times a is minus ab, and negative b times positive b is minus b squared. Notice what happens to my middle terms. They cancel out, and I'm left with a squared minus b squared. So I can factor this now. X squared minus 9 is a difference of squares, so first thing I'm going to do is I'm going to build my houses. The square root of x squared is x, so that's my firsts. The square root of 9 is 3, so those are my seconds. And one of them is positive, and the other one is neg. Notice if I FOIL this back out, this is my factored form right here. This is my answer. Okay, but x times x is x squared. X times neg 3 is neg 3x. 3 times x is pos 3x. And pos 3 times neg 3 is neg 9. What happens to my middle terms? Minus 3x plus 3x. Those cancel. They go away, kind of like me at the party. They go away, and I'm left with x squared minus 9. Let's look at this next one. I have a difference of squares, Notice again, when I say the word difference, that's minus. I have x itself, x squared minus 11 squared. So this is a difference of squares. I'm going to build my houses. I have x plus, x minus, and then the square root of 121 we said was 11. Whoop, whoop. There is my answer, x plus 11, x minus 11. Let's look at the last one. The last one, I have 4x squared minus 25y to the fourth. I have two terms. They're both perfect squares. The square root of 4x squared is 2x, right? That's 2x. And the square root of the square root of 25y to the fourth is 5y squared. So we're going to build our houses. Whoop, 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 whoop. I have 2x, 2x, 5y squared, 5y squared. One of these is going to be plus, one of these is going to be minus. It doesn't really matter which. I could have done minus plus if I wanted to. I could have done minus plus if I lost my plus, my minus sign. There it is. I could have done, if I wanted to, minus plus, but I didn't. If I FOILed this back out, I'm going to get 4x squared. There's that. I'm going to get minus 10y squared, positive 10 xy squared. Sorry, this is minus 10xy squared. This is positive 10xy squared. Those terms cancel out. And then I have negative 25y to the fourth. There's my answer. This is my product form. This is my factored form. Okay, let's do the fun part, trinomial factoring. Trinomial factoring is when I start with a trinomial in the form ax squared plus bx plus c. If the a term, the b term, and the c term are all positive, I know that inside my factors, I call these the houses, inside the houses I'm going to have plus plus. And the reason for that is because when I get my final term, positive times positive is always positive. If A and C are both positive, so if this is positive and this is positive, but my middle term, the B term, is negative, inside my houses, I'm going to have neg. And the reason for that is because negative times negative is still going to give me a positive C. If A is positive, B is either positive or negative, but most importantly, if my last term is negative, I know I'm going to have inside my houses one sign of each, a positive and a negative, because positive times negative is negative, and that's going to give me my final term. So let's go. Okay, when we factor, we are looking at the product form of this is a trinomial that is the product of two binomials. So we need to figure out what two binomials I need to multiply to get to x squared plus 6x plus 8. Looking at my pattern, A is positive, B is positive, C is positive. So when I build my houses, I know I'm gonna have a plus plus. Each of these are gonna be something plus something plus. Now, these are all easy because the number in front of the number in front of the x squared is 1. So this is just going to be 1x times 1x. Those are going to give me my first term comes from the product of my first, which is x times x, x squared. My last term, 8, is positive. So I need to come up with two factors of 8. And they're going to go in these two spots, right here and here, because when I multiply my lasts, I'm going to get 8. So my factors of 8 are either 1 and 8 or 2 and 4. Well, which one of those add up to 6? We know it's the 2 and the 4. So one of those is 2 and one of those is 4. And the reason for that is, now watch what happens when I FOIL this back out. X times x is x squared. 2 times 4, those are my lasts, that's 8. But x times 4 is 4x, and 2 times x is 6x. So x plus 2 times x plus 4 is x squared plus 6x plus 8. This is my factored form. This is my product form. In the second one, I have a positive a, a negative b, and a positive c. So again, I know my signs are the same, but this time, because the b is negative, inside my houses, when I build my houses, I'm going to have neg. Because my a term is 1x squared, I'm going to have x and x. Let's list out the factor pairs of 6. I get 1 and 6, or 2 and 3. Because my C term was positive, I need to figure out which factors of 6 add up to 7. Well, 1 plus 6 is 7, 2 plus 3 is 5, so I'm going to use the 1 and the 6. When I multiply this back out, let's see if it works, and I'll actually write it out. I got to choose a color. Let's choose purple. X times x is x squared. X times neg 6 is neg 6x. Neg 1 times x is neg x. And neg 1 times neg 6 is positive 6. Notice that neg 6x minus x is negative 7x. And that's what I wanted for my middle term. This last one, notice that now my A term is positive, my B term is positive, and most importantly, my C term is neg. So I know now when I build my houses, I'm going to have a positive in one house and a negative in the other. So let's list out the factor pairs of 6. I got 1 and 6. I got 2 and 3. Because the C term is now negative, I need to find a difference of my C factors that equal my B term. So I am going to put my x's in. X times x is x squared. I know that 6 minus 1 is 5, so I want to use the 6 and the 1, so I'm going to put a 6 and a 1. And now my middle term is a positive 5x. It's a positive 5x. So I need to make this a positive 6 and a negative 1. And let's double check. Now when I FOIL, I get x times x is x squared. I get 6 times negative 1. Notice our last terms give us a negative 6. And now I have my outsides is negative x plus 6x gives me a sum of 5x. Why don't you guys try these right now? Let's just kind of run through them real quick. Okay, in this one, the first one, I have A is pos, B is pos, C is neg, so I know I'm going to have a plus minus. In this second one, A is pos, B is neg, C is positive, so in that one I'm going to have a neg. And in the third one, A is positive, B is negative, the 18, and C is also neg, so this one I'm also going to have a plus minus. Notice that in all of these, my A is 1, so these are nicer, but you need to list out the factor pairs of the C term in each to come up with your B term. So list out the factors and go ahead and factor all three of these, and if you want, you can double check each. Okay, you should have had for the first one x plus 12, x minus 3. If I FOIL these out, I get x squared minus 3x plus 12x. That gives me my 9x, and positive 12 times negative 3 is negative 36. We are going from product form to factored form. We're doing the reverse of foiling, correct? The second one, you should have x minus 5, x minus 2. And the last one, x plus 3 times x minus 21. This was a little bit tougher, but we needed to list out the factor pairs of 63, which is 1 and 63, 3 and 21, 7 and 9. The one that works is 3 and 21 because they have a difference of 18. Alrighty. Okay, let's look at these guys right here. Now this is different because there is a number in front of the x squared. In other words, the a is no longer 1. So these are a little bit harder, but the process is still the same. We are reverse foiling. We are factoring. So in the first one, I have a positive A, a positive B, and a positive C. So once again, now when I build my houses, I know inside here I'm going to have a plus plus. And I'm just going to wait. But what I'm going to do is I need to list out the factor pairs of both my A term, which in this case is easy, it's 1 and 2, and my C term, which in this case is 1 and 10, or 2 and 5. Because C is positive, I need to come up with a combination of factors that's going to give me a sum of 9. A sum of 9 because the B term is 9. So let's go ahead and go through this and see what happens. I can take my first pair of the A terms, which is 1, or the A factors, which is 1 and 2, and I'm going to multiply 1 times 1, which is 1, and 2 times 10 is 20. 1 plus 20 is 21. That's not 9. So that didn't work. I can also try 1 times 10 is 10, and 2 times 1 is 2. That has a sum of 12, which again is not 9. So I can actually cross that out. 1 and 10 are not my C's, are not my end, I should say my end terms, which are when I multiply to get my lasts. Okay? So let's try the second pair. I can do 1 and 2 and 2 and 5. 1 times 2 is 2. 2 times 5 is 10. 2 plus 10 is again 12. That's not 9. So let's try it the last way. We can do 1 times 5 is 5. 2 times 2 is 4. 5 plus 4. Let me get my bell. Ding, ding, ding. That works. So I know it's 1x. Let me get my marker. 1x and 2x. Now, the 2 went with the 5. I'm sorry, the 2 went with the 2, so the 2 actually goes in the other house, and the 5 goes with the 1, so it goes in the house with the 2. Both of these are positive, so it's plus and plus. And if I FOIL this out now, I'm going to see that 1x times 2x is 2x. Let me get purple, 2x squared. 1x, my outers, 1 times 5. 1x times 5 is plus 5x. 2 times 2x is 4x. And 2 times 5 is 10. 2x squared plus 5x plus 4x is 9x. So this right here becomes 9x. I have 2x squared plus 9x plus 10, which is what I had to begin with. Okay, this is my factored form. This is my multiplied out form, or my trinomial form. Let's look at 5x squared minus 16x plus 12. Same idea. When I build my houses, I know that inside my houses I'm going to have minus and minus because the C term is positive and the B term is negative. I'm going to list out my factor pairs of 5, which are 1 and 5. I'm going to list out my factor pairs of 12, which is 1 and 12, 2 and 6, 3 and 4. I need to play with my factors until I get a sum of 16. So let's go. Here we go. I'm going to check. 1 with 1 is 1. 1 times 1 is 5. 5 times 12 is 60. 60 plus 1 is 61, not 16. 1 times 12 is 12. 5 times 1 is 5. 12 plus 5 is 17, not 16. Let's try the next row. 1 times 2 is 2. 5 times 6 is 30. 2 plus 30 is 32, not 16. 5 times 2 is 10. 1 times 6 is 6. 10 plus 6 is 16. Hey, hey, hey. Ring my bell. That worked. So I know I'm going to have 1x, 5x. Notice that my first 1x times 5x is 5x squared. Now the 1 went with the 6, so the 6 is going to be in the other house from the 1. And the 5 went with the 2. So the 2 is in the other house. These are both minus signs. So when I check my FOIL, again, as I just said, 1x times 5x is 5x squared. Those are my firsts. My last, neg 2 times neg 6, is positive 12. That works. And my negative 16x comes from my outers, negative 6x, plus my inners, which is negative 10x. Negative 10x minus 6x is negative 16x. Okay, let's try this last one real quick. I know when I build my houses, inside my houses, I'm going to have a plus and a minus. I'm going to have a plus and a minus because I have a negative B with a negative C. Most important, I have the negative C. So I'm going to list out my factor pairs. For the first, I have 1 and 6, 2 and 3. For 40, I'm going to have a whole bunch here. 1 and 40, 2 and 20, 4 and 10, 5 and 8. Very quickly here, I'm going to play with each of my factors. I already know the answer, but I'm going to go through it anyway here. One little key clue to keep in mind, if the B term is relatively small, oftentimes it's going to come from some combination of the smaller factors, but not necessarily, so let's see what happens. So real quick here, 1 times 1 is 1, 6 times 40 is 240, 240 plus 1 is not negative 1. Okay, 1 times 10 is 40, 6 times 1 is 6, 40 plus 6, 40 minus 6 is 34, not 1. Okay, 2 times 1 is 2, 3 times 40 is 120. That does not have a difference of 1, that's 117. 2 times 40 is 80, 3 times 1 is 3, that's a difference of 77. This 1 and 40 does not work. Let's skip down to 5 and 8 just for no we won't. We'll keep going. 1 times 2 is 2. 6 times 20 is 120. Difference of 118. 1 times 20 is 20. I'm sorry, 1 times 20 is 20. 6 times 2 is 12. A difference of 8. That doesn't work. 2 times 2 is 4. 3 times 20 is 60. 4 and 60 have a difference of 56. Let me get my pointer. 3 times 2 is 6. 2 times 20 is 40. 40 and 6 have a difference of 34, not negative 1. So the 2 and the 20 didn't work. Let's get rid of that. Go back to my pointer. Let's try the 1 and the 4. The 1 and the 4. 1 and the 4 is 4. 6 times 10 is 60. 60 and 4 have a difference of 56. That doesn't work. 6 times 4 is 24. 1 times 10 is 10. 24 and 10 have a difference of 14, not negative 1. 2 times 4 is 8. 2 and 4 is 8. 3 and 10 is 30. They have a difference of 22. 2 times 10 is 20. 3 times 4 is 12. Those have a difference of 8. 4 and 10 did not work. Let's try the 2 and the 5. 2 times 5 is 10. 3 times 8 is 24. 24 and 10 have a difference of 14. And my I could have checked the 1 and the 6, sorry. 1 and the 5 is 5. 6 and the 8 is 48. 48 minus 5 is 43, not negative 1. 6 times 5 is 30. 1 times 8 is 8. 30 and 8 have a difference of 22, not 1. Let's try the 2 and the 3 with the 5 and the 8. 2 times 5. 2 times 5 is 10. 3 times 8 is 24, difference of 14. And lastly, let's try this one. 2 times 8 is 16. 3 times 5 is 15. 16 and 15 have a difference of 1. So inside my houses, I'm now going to write 2x, 3x. The 3 went with the 5, so the 5 goes opposite the 3. The 2 went with the 8. The 8 goes opposite the 2. Which one's positive and which one's is negative? I need a negative 1x, so I'm going to do 2x times 8 is negative 16x if I make it negative. And plus 5 times 3 is 15x, so that's a positive. Negative 16 plus 15 is negative 1. If I double check this now, my outers, 2x times 3x is 6x squared. Or my last, positive 5 times negative 8 is negative 40. And now we can see why. If our C term is negative, these must be plus and minus. My outers, 2x times neg 8 is neg 16x, plus 5 times 3x is 15x. Neg 16 plus 15 is negative 1x. Okay, we're almost done, I promise you. One thing to keep in mind, if something times something is equal to 0, then one of these somethings, either A or B, is equal to 0. So if something times something is 0, one of those somethings, either A or B, must be 0. And that leads us to how to solve a quadratic equation by factoring. When you have a quadratic equation, we have a quadratic equation because I have an x squared. If you see the x squared, first thing you must do is set the equation equal to 0. In other words, get everything all on one side. So I'm going to subtract 12 from both sides of my equation right here. By doing that, I'm going to get 0 on the right-hand side. And I'm going to get x squared. I can combine none of these terms. X squared minus x minus 12 on the left-hand side. I'm now going to factor the left-hand side. Well, the factors of 12, they have a difference of 1 or 3 and 4. So I know I have x, 4, and 3. And because my b term is negative, I know it's minus 4 plus 3. So I have x plus 3 times x minus 4 is equal to 0. X plus 3 times x minus 4 is equal to 0, which means either x plus 3 is 0 or x minus 4 is 0. So either x plus 3 is equal to 0 or x minus 4 is equal to 0. To solve this for x, I'm going to minus 3 on both sides. X equals neg 3, or I can add 4 to both sides. X equals 4. So I have two answers here. X equals neg 3 or x equals pos 4. You guys try that next one. You guys try 2 right now. Go ahead and try 2. I'll be back in a second. Okay, so on this equation, the first thing I'm going to do is I'm going to set it equal to 0 by subtracting 4 from both sides. So I get x squared minus 3x minus 4 is equal to 0. I'm going to factor this expression. I know it's plus minus because my c term is neg. I know it's xx because I have an x squared. So this becomes x minus 4 and x plus 1 because negative 4 times 1 is negative 4. And negative 4x plus 1x is neg 3x. Therefore now, if both of those are equal to 0, right, either either x minus 4 is 0 or x plus 1 is 0. So I could say x equals 4 if I add 4 to both sides, or x equals neg 1. Now I'm going to let you guys try that last one on your own. I think I've gone long enough. I hope this helps. We'll see you soon. Have a great day.